Hi everyone, we're doing lesson 1.3 today, properties of graphs of functions. So for every function there are, they can be categorized based on their following characteristics. One being their domain and their range. The domain is basically you can give me any x that you want, and I'll see if I can find a valid y corresponding to that x. If I can, then that x will be part of the domain. And it's the same for range, so you can give me any y that you want, and I'll see if I can find a corresponding valid x for that y. If I can, then that y will be part of the range. Then we have the y-intercepts and the x-intercepts, which are basically the intersection between the graph and the axes. Then we have continuity and discontinuity. So is the graph continuous, or are there breaks in between? Next, we have intervals of increase and decrease. So where on the graph is it increasing and where is it decreasing? Then we have symmetry. Is the graph even or is it odd? Last, we have end behavior. So what happens to the graph at the end of the function? Let's look at a simple one first. Example 1 from your learning resources. The equation is y equals to x. So when you try to analyze this graph, you have to know at first what it looks like, and it's shown here on the left side. Let's look at the domain first. Well, the domain is x belongs to all real number, and that's because for any x that you can give me, I will be able to find a valid y corresponding to that x. And it goes the same for range, so for any y that you give me, I will be able to find a corresponding valid x. So the range is y belongs to all real number. There's only one intersection between the function and the axes, and that's at 0 and 0. So the x and y-intercept is 0 and 0. Next, we can see that the graph is continuous for all values of x, because there are no breaks in between the graph. We can also tell from the slope that the graph is increasing for all values in the domain. Then by looking at the equation of y equals to x, we can see that the function is an odd function because the exponent on top of x, which is 1, is an odd number. Now let's look at example 3, y equals to the absolute value of x. Again, you have to know what the graph looks like in order to do this question. Let's start out by defining what the domain for this is, and that's x belongs to all real number. And that's because for any x that you give me, I will be able to find a valid corresponding y for that. And for the range is y belongs to all real number, such that y has to be bigger or equal to 0. Because in last lecture, we learned that the absolute value of any number is non-negative. There's only one intersection between the graph and the axes, and that's at 0 and 0. We can also tell by looking at the graph that the graph is continuous for all values of x. And when we look at the intervals, we can see that for all x bigger than 0, the graph is increasing. And for all values that's x less than 0, the graph is decreasing. And we can tell that from the slope. We see that the function is an even function because x is an even number and because it is symmetrical to the y-axis. What I meant by that is everything that's on the right side of the x-axis is exactly the same thing as the things that are on the left side of the y-axis. For the end behavior, the ends are heading for the same direction on the y-axis, but it is heading in the opposite direction on the x-axis. Now let's take a look at example 5, y equals to the root of x. And again, we have to know what the graph looks like. The domain for this is x belongs to all real number, such that x has to be bigger or equal to 0, because we don't have any values that is negative. For the range, it's the same, y belongs to all real numbers, such that y has to be bigger or equal to 0. We see that x and the y-intercept is 0 and 0 because that's the only point in which the function intersects with the axes. We can also tell that the graph is continuous for all values in the domain. We can also tell that the graph is increasing throughout the graph by the slope of tangent. The square root has no symmetry, therefore the graph is neither an even function nor an odd function. That's all the examples for today, and remember to do your assignments as well as upload them for the teacher.